Kind greetings to you all. I'm back. Mwalimu Arnold Sekago, series of carbonyl compounds. What are we on? Preparative techniques. Preparative techniques, I think I had covered most of them. What am I left with? Reduction of acyl halides, that was covered. I think I have only one, isn't it? I'm left with only one. Oxidation was covered, hydrolysis via Reginald. We saw that reduction of acyl halides. I have only ozonolysis. Twendell-Crafts acylation was covered. Yeah, Twendell-Crafts acylation was covered. Hydration of alkynes, yeah, they were covered under what? Under alkynes. Analysis. So I stopped on mild reduction of acyl halides. Mild reduction of acyl halides. Now I want to continue with the ozonolysis of alkenes. Still, it was covered. However, there is a certain group which I teach, which is not familiar with ozonolysis. Now, for ozonolysis, still I'm going to be very quick. Ozonolysis of alkenes. Ozonolysis. This is ozonolysis. Analysis of alkenes. What does this mean? Ozonolysis comes from two words: ozone and lysis. So basically, this by ozonolysis we mean reaction of alkenes, with the ozone, followed by hydrolysis, with the water in the presence of what? With water, followed by hydrolysis with a reaction of alkenes with ozone, followed by hydrolysis with water in presence of zinc. In presence of zinc, I think it is zinc and ethanoic acid. Yeah, it is. Anyways, the syllabus emphasizes the first one, which I commented. So this is that I'm adding them for those of you who read a lot of books. So with water in presence of zinc and ethanoic acid. Anyway, I'll see when I write it whether I've missed something. Followed by hydrolysis, it is reaction of alkenes with ozone, followed by hydrolysis with water in presence of zinc and ethanoic acid. So ozone is O3, and the reaction with ozone, the reaction with ozone occurs in presence of what? In presence of an inert solvent, tetrachloromethane at now these are very low temperatures, and I'm going to explain why. Reaction with ozone occurs in presence of an inert solvent, for example, tetrachloromethane, at 5 degrees Celsius. Why? Why 5 degrees Celsius? I'm going to explain why. For example, if I have my CH3, CH, propene reacting with the ozone in presence of tetrachloromethane at 5 degrees Celsius. Ozone will fix. It is an addition reaction. Alkenes undergo addition reactions. So ozone is added to the double bond. so that we get CH3, CH, O. There are 3 atoms of oxygen, CH2, O, that. Then followed by, now this is what we call an ozonide. This is an ozonide. An ozonide, which is very unstable, and can explode. An ozonide which is very unstable and can explode. That's why the reaction occurs at very low temperatures, very low temperatures. Yeah, in some books you can find that it is even below 5 degrees Celsius. Very low temperatures due to instability of that ozonide. And that's why you need an inert solvent, a solvent which is reactive. So then this is hydrolyzed with water in the presence of zinc, carbonyl acid. So once it is hydrolyzed, the compound is split into two. It is split into two so that we get this part here, that part in pink. We get that part in pink and another part in pink. Then this oxygen combines with water to form hydrogen peroxide. So we get CH3, CHO plus. Now this other part here, that is the methanol. Then plus a minor product of hydrogen peroxide here. This oxygen here adds to water. That oxygen which is left within the structure adds to water so that we get the hydrogen peroxide. Another example. For example, if I have CH3, this is also an alkene, double bond, CH3 with the ozone. Inert solvent, 5 degrees Celsius. Ozone is added to the double bond so that we get CH3. There is O here, then CH3, O there, then also this carbon here, O, like that. Followed by lysis. This is ozonolysis, followed by lysis. That product which you see there is unstable. That's why the reaction has to be carried out at very low temperatures. Followed by lysis, water, zinc, carbonic acid. What do you get? Propanol. The compound is split. Look at that part in red. This part in red there. Propanol. Then plus the other part also in red. Ethanol. Like that. Yeah. So it is important to note that also another example. Suppose that I have ethene. One can also combine those two steps. Number one, you have 5 degrees centigrade. Number two, water, zinc, carbonic acid. Now here we get one product. One product, there are two products, but they are the same. So almost one product. What? Methanol. Now it is important to note that the symmetrical alkenes, Ig, for symmetrical alkenes, I mean alkenes of this form, R, C, RCH, double bond, CHR. They have a line of symmetry. What is that line of symmetry? That line you can see in pink. That is the line of symmetry. As in, when you try to draw a line of symmetry where you have a double bond, what is on the right-hand side is the same as what is on the left-hand side, like ethene. Ethene is symmetric. If you draw a line here, what is on the right-hand side is the same as what is on the left-hand side. So that alkene is called symmetric alkene. For symmetrical alkenes, they yield one product. They yield one product, whereas the unsymmetrical, in some books they call them asymmetrical, whereas unsymmetrical alkenes are asymmetrical. If it's not unsymmetrical, it is asymmetrical. Whereas unsymmetrical alkenes, which ones? For example, if I have CH2, this is not symmetric. When you do a double bond, a line of symmetry, what is on the right hand side is not the same as what is on the left hand side. Like which example? Like this one here. You do a line here. What is on the right hand side is not the same as what is on the left hand side. So I want to say that whereas unsymmetrical alkenes, for example, this one, yield different products. Different products that can be separated by fractional distillation. Yeah, if there are different products, they can be separated by fractional distillation. Yeah,